So we're on box number 13, unlucky for some. It's one of my favourite radios. Harvard 420M. It's come with a power lead and a microphone. We'll be doing the things on our microphone and power lead, but then we'll check this at the end. So I suspect that probably said something else and not Harvard. But nevertheless, they were that tight. Well, I was certainly pleased with the Maxcom 6E, which was the last job we did. I've been attacked by a Mad Amstrad chassis. Oh, it's a Mustang. Yep, Harvard 420M with a migrating screw. So we'll use our power lead for now. Put the PA speaker into there, and we'll put the instrument test speaker into there. We'll get the cybernet mic. That's the one that handily says cybernet on it. Switch the power supply on. I'll start it at 9 volts 300 milliamps because I don't know the story behind the set. I will just have a look at his letter, but he's got his address on it, so please find enclosed my Harvard 420 the service and alignment. There we go. And that's from Brian. Right. Switch on power supply from standby to on. And switch radio on. That's fine, it's drawing 205 milliamps. So we'll go to 13.8 volts, current limited to 1.6 amps. And there we are. So check that's there. That's a bit stiff. That's a bit stiff. That's a bit stiff. So we'll start by checking PA. Testing 1, 2, 3, 4, 5. That's the end of that test. Right, so we'll get the clipboard. We'll be doing this for all the sets, seeing as these have happened. Goodness knows what the date is. Let's put it down as the 25th. I really don't care. I do know I've not got any weddings to play the organ for today, otherwise I would care. So it's a Harvard 420M 1110 1341. So at the moment the meter lamp is okay and the PA function is okay. So let's go over to CB, switch picture in picture on. And we'll press transmit. So it's transmitting, it's doing over 3 watts, it's doing 3.4. Let's see how balanced it is. Channel 1 is doing 3.2. Supposed to be within 0.1, but you can't always get that. and channel 40 is 3.2. That's absolutely perfect if we can just bring it up a little bit. Low power, go back to channel 20. Low power not working, and the transmit current is 1.088. Deviation, wallow. Oh, I'm in the wrong mode, aren't I? Wallow, absolutely spot on. 1, 2, wallow. We're not going to be touching that. Well, we are. We're going to make sure that it's set how I want it to be set. Frequency, because you've got two adjustments on these. Frequency 2779. It's a little low. 27799090. And let's do the synad. So I need to set the signal generator the same as what the radio is on, which is 27799090. I've said before, if you adjusted the if you tested the receiver on the correct frequency when the radio is off frequency, it would be a very unfair test. So we set the frequency the same as what the radio is transmitting on. You can't do that on all sets. Things like the DNT have got multi-crystal mixers and transmit and receive frequencies are separate, for example. So, synad. We'll switch the synad meter on and we'll put the picture-in-picture onto the synad meter. Put a bit more volume on, making sure RF gain's at full. No, that's not good. We'll have to go up a notch. No, it's not good at all. It's just over 1.5 microvolts. Really needs to be under 0.7. I'd let it go at less than 1, but that's not good enough. So let's look at 10. So it's 1.2. If it will do 20, not all sets will. This will. It's only down to noise. It doesn't affect your range, this one. It's 4.4. So our squelch, set threshold. Squelch isn't working properly. I think it's been modified by a silly Billy. So it now hisses all the time, but doesn't hiss as much as if the squelch wasn't there. It's difficult. Let's turn the volume up, see if you can hear. So I've got it on full volume. So that's the radio hissing at the moment. Let's turn the signal generator to standby. And then we advance the squelch. I mean, that's the wrong kind of FM noise anyway, it's too quiet. All it does is just turn it down. You can see on the synad meter. So on full squelch, let's see what we've got. It's 300 microvolts. So I could say, let's go back to that beginning. It was minimum was 0. So somewhere at 0.55 microvolts, and full is somewhere like 300 millivolts, but because it's not working properly, 300 millivolts, yeah. So what's the S9 on the meter? It's well screwed up, this set, isn't it? So there's S9, so it should be 100 microvolts. In fact, it is... It's 175. Just go back to transmit and we'll just look at the RF meter. That's banging across. So we put FSD for full scale deflection. Meter lamp's okay. Let's check channel 9 works, channel 9 works. So because low power doesn't work, I can't tick that off yet. These are working, and those are working. Good. Well, that's a start, isn't it? So we've got a really messed up squelch, and it will have been, I think the phrase is, farted about with. So I'm going to take all the screws out bar one, because we know we've got to take the top lid off, because we know it's going to have been messed with. Well, this set's from Rotherham, and I came from that kind of area originally. And I learnt to play the organ at Wiston Church, which was a village kind of between, well, I'd say Rotherham and Sheffield, but not quite. Rotherham and Brinswood, shall we say. And there was one flaw in that excellent tuition. The organ was 1913 Norman and Beard, and it was pneumatic action, so it's power assisted. Now the organist, Mr. Norris, there was a deputy organist, Mr. Cook. Mr. Cook, he had a father who played the organ at another church, which was St. Cuthbert's at Broome, and they had a mechanical action pipe organ, like nearly all the pipe organs I see, like all the ones here, like all the ones I play. Wouldn't it have been sensible if I'd have done some practice at St. Cuthbert's Church, which was actually only 3/4 of a mile from my home, instead of practicing the organ at Wiston Church, which was a mile and a half away from my home? Because when I got my first professional organist position at Tinsley, Sheffield, where it was mechanical action operated organ, I could hardly press any notes because I'd been used to a power assisted action. Now that was silly. It's like learning to drive on a car with power assisted steering, and then you buy one which isn't. Right. Anyway, Mr. Nice was wonderful, but there was a flaw. I could see as an extra wire there, that is going to be going. That's this stupid Squelch modification. So we're going to start with the VCO on this radio. Right, let's take that camera back to that one. Put the other glasses on. So resistor 4, we want channel 40. And we want far end of that resistor, and it should be 4 volts on receive. 4.1 is acceptable. I think 4.2 is acceptable. At least on these sets you get what it says in the book on the cybernet chassis used in the Amstrad chassis and the Harvard 402 and Harvard base station. It isn't quite what it says in the book, and it's experience that tells you how it should be set. So there we go, that's right. Now we're going to transmit. There's always a settling down period on transmit on these. I'm going to waggle that about a bit in case it's dirty, and we'll start again. Okay. So now we have to go back to receiver because they are interactive. I'm just going to touch that a minute. See if it's turning it the wrong way. Go back to transmit, and that will just start dropping, which it does, and then back to receive, and that starts to come up a bit. Right, channel 1, that's alright, needs to be between 1.8, 1.9, 2.3, 2.4, so that's spot in the middle, and that comes to where it should be, so there we go. I don't think it would have been malfunctioning as it was, but whilst it's here it may as well get the VCO done. I've forgotten already what it was. I should have written it down as I went. I think it was something like 4.2 plus 3.8 or something like that. It was neither here nor there anyway. Turn to Squelch down. You know what? I'm gonna have to demodify this Squelch thing, and because it's so awful the way it is at the moment, it just doesn't sound right. Whether or not that's a detector out, it is frustrating. I bet people even, these rig doctors in inverted commas, I bet they even charge for the privilege of knackering up these type of things. But I'm not going to charge to demodify it. Right, here goes. Transmit. So we're now 3.4 watts. Let's check we're on channel 20. We're not. Tell you what, we'll put it on frequency first. It's all been on long enough. Try and get transmit done, then it's lunchtime. Probably because I can't be feeling like doing that Squelch demod. Right, let's bring that up. not going that way. It is going that way though, so we're all right. I'm not going to. I would like to have them about 126. It's no, it is toggling to 124. So I'll just bring that up. It's so difficult to get them absolutely spot on where you want them. It's all neither here nor there. Right, we've got it at 128. So that's where it is. Just in case it's the preset that's dirty, because they often are, that can be settling itself down. I'll put it back to about where it was. Here goes, transmit. So 3.4 watts. Peaked it there, it's still 3.4 and a tiny bit. Try and get that there. 3.4 and a bit. 3.5 and a bit. These are the ones which you need to do quickly, because some of these radios will do about 5.5 watts, but the transmitter can't sustain that for very long. I've said before, when we were doing business radios, we had the M201 Pi Olympics AM high band, and they had a 60 watt PA, so it was really on top of the job, but it was a 10 watt radio, and you had to turn it up to full, and smoke started coming out of it after about 10 seconds. And these aren't that far behind. Some of these chokes will overheat, and then you get the wally who thinks that you can turn it up and leave it like that. So legality aside, you can't. So that's maximum. So we're at 3.6 watts. That's 3.7 watts. That is 4.2 watts. I'm going to go through them again. Peak, peak, peak. It's about 4.2 watts. Now, I'd like it to be 4.4, but it isn't, because the service manual says that we need to reduce this to 4.4. Well, it's already there, isn't it? So we need to turn it anti-clockwise till it starts moving. In this case, it started moving, so we need to turn this one clockwise. Am I doing this right? It's a few days since I did one of these, and because I've got a memory like a sieve, we do have to keep checking. Tell manual, because Harvard couldn't be bothered to do any. I did write to them. Just make sure we're doing this right. I'm doing it exactly wrong. So we want that back to peak, that back to peak, that back to peak. Okay, so L4 is clockwise till it starts moving, and L9 is anti-clockwise. There we go. So it's supposed to be set for 3.8 watts, but we try and do it to the legal limit. In this case, the radio is about 3.9, but it is warm. So I'm going to leave that till we take the readings. But what I'm talking about leaving that, I'm talking about leaving it for 30 seconds. So let's do this transmitted audio, because although it was right, that isn't in the position I want it. So we're just going to do that on the deviation. So let's just key that up. It's possibly too loud. Wallow. It's so minutely too loud, but we'll just deal with it. See where that's better. Voila. So it's exactly the same result as it was before, but now the feedback bit of the circuit is set how I want it to be set. So that's that covered. Let's look at low power. Switch it to low power. So now we do have low power. It's so small it's off my scale. So I think we've got a broken preset there, because it won't come up more than 200 milliwatts, and it's kind of dodgy, shall we say. So that's something else to come back to. I'll get a preset out. Right, we'll unpower it and take the bottom off. I'm going to deal with that squelch situation at the same time while we're doing some engineering work to it. May as well do that. I've even had somebody put a comment on one of my videos of this type of this chassis, suggesting this squelch modification, and absolutely ridiculous. We take that out. I can't remember. Oh, no, we'll go for lunch because that needs putting the soldering iron on. So we'll go for lunch, and when I come back, we'll deal with that. Right, so here we are. I've done those engineering things. So I took the pink wire out, and the 10k resistor was missing, which is resist 60. So I've put a new one in. I'll put a new preset in there. So it's supposed to be 300 ohm. I think I've put 220 in. We can't get 300. The alternative would be 470. It'd still work the same. So we'll start by trying to set the transmit power up on low power. See what we get this time. And straight away we were able to get 400 milliwatts. Yep, very satisfactory. So we've now got squelch action. The radio still sounds absolutely horrible. Thin and weedy and nasty. So we're on frequencies. We've now set the signal generator for 2779125, the correct frequency. Oh, it could be my jack plug, of course, which is thin and weedy. Yeah, my earth's off. Trouble with these things in and out all the time. Anyway, it's nice to hear squelch action back on this radio. Is that the right socket? No, that's the right socket. So now we've not got the weediness. Right, and you can hear squelch. Normal. So first of all, we're going to set the detector. So put the oscilloscope on, put an S9 equivalent signal on, 100 microvolts. And check this is at maximum. Yeah, that was fine. That surprises me. So now we'll turn the squelch down, make sure the RF gain's up, and we'll put the cyanide meter onto the inset picture. And see whether we can improve that dreadful receive sensitivity. Oh, that's come up quite a lot. Put a bit more signal on for the next one. This is the extra one you get on this model, which you don't get on the Rotel 220 and Rotel 230s. It's 50-50 as to whether you get this. Yep. Yep. And then there's one lurking under this wiring harness. Like that. Let's see what we've got now. Yeah, 0.45 microvolts. The 10 dB for 2 microvolts. And the 20 dB we've got 1.4. So we're going to check this transmit power, which we'll go back to now. It's cooled down. So channel 20, I'll just turn the volume down so as not to annoy everybody. Channel 20 when we're on the right mode is actually now 4.1. Channel, I may have to bring this down if the others rise. Channel 40. Channel 40. 4.1. So that's balanced well enough. Low power is 400 milliwatts. We've just done that. We'll go back to channel 20 and check the power consumption, which is now 1.37. So put 100 microvolts on the signal generator. We'll go over to the attenuator to 100 microvolts. Let's look at the meter. It's on the plus of plus 30. So that's now 9. And we now need to do the squelch. So full squelch. 1, 3, 10. I want it to be 100 microvolts. 30, 100. It's spot on. So actually, when the thing's got rid of that silly modification, it has not needed adjustment. It's the preset down there if it did need adjustment. So that's excellent. Whoops, I'm moving my stuff here. So that's now for what? S meter is now correct. Squelch, the full is 100 microvolt, which is where I want it. And let's see where the sensitivity lies. So we're going to turn the signal generator to standby. It's parked at the 0.3 of a microvolt. Set the threshold on the radio. And let's see where it comes in. It's 0.55. So it is the same. That's absolutely fine. So it comes in at 0.55. It drops out about 0.46. And I've said before, the squelch is never the best in the world on these radios. It is only a level squelch. It's not a noise squelch. And it's adequate. It's competent. It doesn't want farting about with like that. dreadful. And I'm seeing this time and time again, so there we go. So, we've got some slightly stiff controls here. I'll probably take the knobs off and apply some WD-40 to the shafts. Don't need to apply a switch cleaner because none of them are noisy. Never use WD-40 ordinary lubricant as switch cleaner, though I do know they do a switch cleaner, which is a different product. So we're actually done, and it's now a very satisfactory radio. So 2 parts, 10k resistor, 200 ohm preset, and we've now got lovely performance. So I'll be looking forward to doing that round Scratchy Corner later on. So we may as well unplug that from the instruments. Unplug that from there. I'm not going to put all the screws in front of you. You don't need me to show you how to use a screwdriver. I'll get those Midland 4001s packed off. And so it's box 13. And this can wing its way back to Rotherham. I know we've got a couple of relatively modern sets which I'm not sure we're going to be able to get anywhere with. I know we've got one of those. I don't really don't get on with them. I don't think they're a good set. They're each to their own. The Night Watch Cobra 25, about 1999, 2001, that kind of era, and they don't seem to ever work well for me. Anyway, this guy's, I wouldn't normally accept them in for repair, but this guy's owned it from new. Yeah, you are, bigger speaker. So I will have a look at it. And he's also sent in, he's got a lovely set of radios, hasn't he? An EM27 Maycom, and which is going to go wah when he switches on. Now he reckons it's the later version which doesn't have the battery, so there we go. But I've no experience of ever getting any of those to work, but then every time I've seen them they have been messed with. Well, this won't have been messed with, so we have got a fighting chance. But it may be 2 videos of not fixing sets before we move on to something which we are able to do something with. Because sets with surface mount components are obviously going to be less fixable than radios with leaded components such as this. The other side about those Maycoms is they are a multi-printed circuit board, multi-layer printed circuit, so if something happens in the middle, you know, it's a bit like computer boards, isn't it, where they're multi. So you haven't just got a front and a back, you've got something in between. I think if we put 3 in for now, just so we can finish this video, it's not going to be waggling around. There we are. We're going to check his mic. I'll just check that later on the air test. So if I can find where our Solarcon 99, Antron 99, Cadbury's 99, whatever it is, 99, red balloons. There we are, on the aerial. 19 Roger. You'll be lucky, they're all having lunch. He's over deviating. He sounds alright, apart from the echo. And all the bars that work on the display. Okay, it can chunter itself on 19. Very satisfactory result. So thank you for watching the Harvard 420M from 1981 and using the Cybernet 134 chassis.